T8.13. Do props make a difference when researchers interact with their subjects? Emily and Maddie asked 100 people if they thought buying coffee at Starbucks was a waste of money. Half of the subjects were asked while Emily and Maddie were holding cups from Starbucks, and the other half of the subjects were asked when the girls were empty-handed. Okay, so half means that the size of the first group is 50, the size of the second group is 50. Okay. The choice of holding or not holding the cups was determined at random for each subject. Okay, so we have random assignment here. When holding the cups, 19 of 50 subjects agreed that buying coffee, okay, so with cups, without cups. All right, so the first sample proportion, that's 19 out of 50, which is 0.38. The second sample proportion, it's 23 out of 50, so 0.46. Okay. All right, calculate and interpret a 90% confidence interval for the difference in the proportion of people, like the ones in this experiment, who would say that buying coffee from Starbucks is a waste of money when asked by interviewers holding or not holding a cup from Starbucks. All right, so for 90% confidence, the critical value that we're going to be using is 1.645. Okay, so Z star 1.645. All right. Now, we've got to follow the 4C method when we create this interval, right? And this ensures that we have everything that we need in our response to get maximum points. All right, so a good activity to refer back to would be the prom activity, juniors versus seniors. This is a very similar situation. All right, so the name of the procedure, this is a 2-sample Z interval for estimating P1 minus P2, right, which is the difference in the true proportions. The parameter is the true difference. Make sure you include the word difference here. In the proportions, proportion of people like the ones in this experiment who would say that buying coffee from Starbucks is a waste of money when asked by interviewers holding or not holding a cup from Starbucks. Oh gosh, I know that seems ridiculous to have to write all that out, but that is just kind of the necessary evil of this class. Is there's a lot of writing. It's not just math. Okay. All right. Other thing we should probably mention here is the confidence level is 90%. Okay, so that's all you have to do in the choose step, right? Is name the procedure. Forgot to label that. Define the parameter, and then state the confidence level. Now, if you want to include notation here, the notation for the parameter is just P1 minus P2. All right, here, let me move to this empty space over here. Let's check our conditions, okay? So this is an experiment with random assignment. All right, and that satisfies the random condition. The 10% condition is not needed right? You only have to check it when you're sampling without replacement. And since this study doesn't involve any sampling at all, it's an experiment, you don't have to check the 10% condition. All right, the large counts condition. Okay, so we have to check N1, P hat 1, N1, 1 minus P hat 1, N2, P hat 2, and N2, 1 minus P hat 2, right? We have to make sure all of those are at least 10. Okay. All right, so let's start plugging in some numbers. All my numbers are up here. So we got 50 times 38%. So 50 times 0.38, which I know is going to be 19. We're going to have 50 times 0.62, which is going to be 31. Okay, and we're going to have, the other numbers are 50 and 46%. Okay, so 50 times 0.46, which is 23, and 50 times 0.54, which is 27. Okay, yes, every one of those values is at least 10. All right, so it's safe for us to move on to the next step, which is actually calculating the interval. All right, 4 things that go into this step. General formula, all right, and that's the same every single time. Point estimate plus or minus margin of error. Okay, then the specific formula. Okay, so for the specific formula, if you don't have it memorized, you're just going to recreate it using your formula sheet. Okay, so this is your point estimate. Okay, P hat 1 minus P hat 2. Let's go ahead and put that into parentheses, plus or minus. And then the margin of error, that's your critical value times your standard error. The critical value is just your z-score. And then the standard error, if we go to that column there, it's right there in the center of the screen. It's that long square root expression. Let's see if I can fit this in. P hat 1, 1 minus P hat 1 over N1, P hat 2, 1 minus P hat 2 over N2. Okay. All right. Now that we have the specific formula written in notation, next is to plug in the numbers. Okay. So P hat 1 minus P hat 2, that's 0.38 minus 0.46. Plus or minus. Now our critical value, I wrote that down up here, 1.645. All right, and then now the standard error part. So this will be 0.38 times 0.62 over 50, and then 0.46 times 0.54 over 50 as well. All right, and at this point, I'm just going to go ahead and just type this whole thing into my calculator. Well, I have to do it separately. So once when I subtract, and a second time where I add. Okay, so after doing the calculations, I got negative 0.242 for one endpoint and 0.082 for the second endpoint. Okay, so we chose our procedure, we checked the conditions, we calculated the interval. Finally, we have to write a conclusion. Okay, and the conclusion is just one sentence following that template. We are blank % confident that the interval from A to B captures the true context. Okay, so our confidence level, that was 90%, so let's go ahead and write that in, 90%. The interval itself was negative 0.242 to positive 0.082, and then the parameter, all right, I'm just going to copy and paste it from the choose step. guess put it here. All right, so I know it doesn't look nice, but I'll read it out. We're 90% confident that the interval from negative 0.242 to positive 0.082 captures the true difference in the proportion of people, like the ones in this experiment, who would say that buying coffee from Starbucks is a waste of money when asked by interviewers holding or not holding a cup from Starbucks. Ugh. All right, it's a mouthful, but all right, that is the best we can write for the interpretation. All right, so that was it. There was no part A or B. It was just use the 4C method to construct and then interpret the interval.